Greetings, 7th graders. Welcome to the last lesson of Unit 4, where we will discuss some of the properties of arithmetic. And our learning target is I can identify how the properties of arithmetic show up in our algebra work. So starting with the commutative property of addition and multiplication, and I want to highlight this word, commutative. Keyword, commute, which means to travel. A lot of us commute to school, meaning we travel from one neighborhood to another in order to get to Oxford. And this idea of commuting is key to the property, the commutative property. In addition, this shows up meaning that the commutative property tells us that if two terms are added, then the order may be reversed with no effect on the total. Example, a general example using variables, if you take any number A plus any number B, it's going to equal the same amount as if you have that same number B plus that same number A. You can see that as a numeric example. We could say 7 plus 12 equals 19, just as 12 plus 7 also equals 19. This property also holds true with multiplication. If we have two expressions being multiplied, the order may be reversed with no effect to the result. Example with general, just using variables, any quantity A multiplied by any quantity B is going to be the exact same value as that same quantity B multiplied by that same quantity A. The numeric example of that would be, we know that 5 times 8 equals 40, just as 8 times 5 equals 40. Those expressions can change position without changing the value of the equation. Now, this property holds true for addition and multiplication, but not subtraction and division. And the reason for that is, for subtraction and division, order matters. An example, 5 minus 2 does not equal 2 minus 3. 2 minus 5. 5 minus 2 is 3, whereas 2 minus 5 is negative 3. And same for division. 4 divided by 2 does not equal 2 divided by 4. 4 divided by 2 is 2, and 2 divided by 4 is 1/2. The commutative property is really helpful when we are working with combining like terms, because when we are combining like terms, the only operation we are really using is addition. For example, with an expression like 3x minus 4x plus y minus 2x, we can rewrite this expression using only addition. It would look like 3x plus negative 4x plus y plus negative 2x. And this shows up when we build tile models. Because even if we are combining with some negatives, if you're using a tile model, you're still adding negative tiles to your pile. And this commutative property, this idea of addition, it allows us to move terms as needed so we can organize our work. So using that same expression, because the commutative property of addition says that we can move things without changing their value, we can rewrite something like this now and move all of our x terms together. We can rewrite this as 3x plus negative 4x, and then take that term at the end, this negative 2x, and bunch it with our other x's. So you could say plus negative 2x, and then leave our unlike term y at the end. And with an expression like this, we might see this and be able to do this in our head, but if you have a lot of terms, it's going to be really handy to just remember to combine things without losing whether they are a positive or negative term. So now we can do our actual math and say 3x minus 4x is going to be negative 1x, or just negative x, plus 2 more negative x's, plus that y, which simplifies down to negative 3x plus y. The second property we're going to remember about is the associative property of addition and multiplication. And the key word of the associative property is associate, which in general terms means like to be grouped with. You can think if you're in my class, Miss Sayers' class, then you are associated with me and with the other students in my class. If you're in Miss Saylor's class, then you are associated with Miss Saylor and the other students in Miss Saylor's class. And this shows up for both addition and multiplication. The associative property of addition says that if a sum contains terms that are grouped, then the sum may be grouped differently with no effect to the total. So once again, we're seeing no effect to a total. The general example of that is some number A plus some numbers B and plus C should be equal to that same number A plus B plus C. And the reason this works is because of order of operations, which I always think of as PEMDAS, with that P meaning parentheses first. So let's do this numeric example. Here we have 3 plus and then grouped 4 plus 5. So order of operations says that this is actually 3 plus 9. And is equal to, in this case, 3 plus 4 are grouped. They are associated. Therefore, we have to do that first. So that is 7 plus 5. And these are equal because they both equal 12. Now this also works for multiplication. It says if a product contains terms that are grouped, then the product may be grouped differently with, once again, no effect. So once again, we can have these numbers A, B, and C and say that we can multiply A by B times C or multiply A times B times C. And this will give us the same numbers. So let's try this out with 2, 3, and 4. And indeed, 2 times 12 is equal to 6 times 4 because they both equal 24. Okay, and once again, this does not work for subtraction division because order matters. If we group 2 minus 4 minus 3, this becomes -2 minus 3, which becomes -5, and that does not equal. Again, we have to do parentheses first. So 4 minus 3 is 1, and 2 minus 1 is 1. So -5 does not equal 1. One place I see this idea show up a lot, this associative property, is when we are doing long expressions and parentheses become involved. I want you to pause this and do your best to simplify both of these expressions and see how the addition of this grouping right here in the second expression changes the value. Go ahead and pause, come back for the answers. Here are my final answers, and I went ahead and also added what I did with each step. In your journal problems, you're going to be asked to do this, and so you can look back at this as an example of see where I used associative property, where I used commutative property, and where I combined like terms and simplified. You can see the difference between grouping 5 and 8 and doing that first. You end up with 3x minus 2y minus 3 right here, and not having that associative property, not associating those two terms, you end up with 3x minus 2y plus 13. Now, special bonus for anyone who wants to, I'll give a piece of candy for anyone who looks back at the meme on that beginning screen and writes me at least a sentence about which property of arithmetic that we talked about today you think it represents and why. All right, go ahead and grab those journal problems and let us know how we can help you. Y'all rule.